Hi, professors. So I'm Nikita and this is Harini, and our project is on IMDb analysis. And in this presentation, I would like to talk about our index. Our index has introduction, analysis, algorithms, visualizations, business suggestions, and lastly, we conclude the topic. Now, Harini will talk about the introduction.
Hello, Professor. So, as Nikita mentioned, we took our movie IMDb as a topic. So, it's an international movie internet movie data set. So, which is available in online data set online. So it's not only data set, but it's an world most popular and authoritative source of movies, and it's also an influence box office for performance to shaping the audience or public opinion on the movies or the film industry. So it plays an important role for the movies and entertainment industry. So if a movie is being listed in the IMDb rating, it's an honor for the filmmakers and artists, and it can be recognition for the within the industry for them. So coming to our analysis, this is our analysis, and these are the variables which are present in our data set, and our target variable is IMDb ratings. So this is a SpicePark environment. So we took our data and did our data cleaning by removing the missing values and impurities, and we took the cleaned data and did our algorithms on linear regression, gradient boosting, and random forest. And coming to the visualization, this, as we can see, it's one of the it's an bar graph which represents the distribution of IMDb ratings, and most of the ratings are based which lied on 7.28 8 points. So on x-axis we can see ratings, and y-axis represents the frequency. And coming to the another graph, it's an correlation heat map. Which represents the correlation variable within runtime, IMDb ratings, and Metascore. And so coming to the numbers, the 1.00 represents the correlation variable within itself, and the 0.24 represents the correlation coefficient between the runtime and IMDb ratings. IMDb ratings. And coming to the next number, which is in the negative, minus 0.02, it shows an weaker negative correlation between the runtime and Metascore. And coming to the 0.28, it shows a correlation coefficient of between the IMDb ratings and Metascore. And coming to the next graph, it's a graph which represents the Metascore. On the x-axis you can see that it represents the Metascore, and the y-axis it represents the frequency. It's an histograph, and this bar graph shows the most particular Metascore range between 60 to 80. And as we can see, the highest Metascore rise between 60 to 80, and it's most concentrated and the score of the range. And coming to the next graph, it represents the most common genre which is seen by the public. And as per data set, we got that most common genre seen by the public is drama, and it shows an highest score of which lies between 60 to 70. My friend will continue with that.
So here we see the two graphs, which is one of them is scatter plot and the other one is histogram. In our scatter plot, we actually are showing the relationship between actual and predicted values, where the red line likely to say the identity called as identity line, where predicted and actual values will be equal. If it's the dots are scattered around but it's not on it, where it indicates that the data varies between what the model predicts and what the actual values has been shown. And the other graph, which is a histogram, shows the movie length and the frequency. As we clearly see, there was less duration of the movies which were like 150 less than there is less range of movies which were standing in between 50 and 100 minutes, and there were less between we can say from in after 200, but there were a high frequency between 100 and 150, which you can clearly see in the graphs. And next, we would like to talk about our project analysis. Like as Harini mentioned, our algorithms were random forest, gradient boosting, and decision tree. I would like we after doing all the going through all the data cleaning in the process, we clearly state that gradient boosting stands out the best. The reason having its least score MSE. As a mean score error is comparatively less than random forest. The random forest and gradient boosting stand same, but reason being its mean score error is bit less than random forest. We wanna say that gradient boosting is great for this great fit for this data. Among the random forest and decision tree, random forest stands a bit more on a top self than decision tree. So firstly is our gradient boosting, and second the random forest were the ones which we select would be great for this data. And next we would like to talk about our business suggestions. Next slide, please. So the first main thing which would be great, we thought would fit this industry, was predictive analysis platform for studios and the producers. So thinking from the point of view to people who invest in this movie industry, we would like to say it's a big investment, and people in the film industry are highly competing and financially institutive, and the studios producer constantly seeking insights to minimize the risk of the sessions. As we see, it's a process with high investment, time, and a lot of work. The financial impact can be a bit more on a long run. So if we bring out something which our analysis mentions with all our graphs, like how a genre can be reached audience more than not the other, and how the frequency of movie length can have an impact on them. By this, the financial impact by enabling more accurate predictions about the movie successes from the past decade can make a change on differing from them to see which one they can invest and which one they can bring out to be as a best one, and which would help them to bring out a less risk on this investment and can bring more ROI, which is return on investment. And lastly, we would like to conclude the topic. Throughout this presentation, we are exploring the potential applications of advanced big data analysis, and within the context of entertainment industries, where we specifically use this rich data of IMDb. Our project not only demonstrates how data-driven insights can be extracted, but also be showcased throughout our practices and implications through the predictive models such as gradient boosting and random forest and decision tree. Thank you.